So hey guys, welcome to the channel Learn Competitive Programming with CodeChef. So if you want to learn competitive programming and get a good hold on data structures and algorithm, this is the right platform for you. Every week there are several videos which will enhance your skills in DSA as well as competitive programming and the editorial videos of the CodeChef contest. So if you're new to the channel, then do subscribe the channel and turn on the bell notification. So myself Chirayu Jain, I'm a CodeChef educator, and the problem that we are taking today in the series of stack and queue is stack versus queue. Okay guys, so now let us start the understanding of this problem, that is stack versus queue. So we have seen a similar kind of problem in that is queue versus stack. So if you not watched that video, you can watch that video as well. So in this particular video, in this particular problem statement, what we're trying to say is that initially chef has an empty stack, that is S. Chef doesn't know the stack data structure, but he masters the queue data structure. So he wants to build the stack S using exactly two queues, right? So what is the requirement here? He doesn't know about the stack. He doesn't know about the stack data structure, and he knows about the queue data structure. So what he needs to do is he needs to build the stack S using two queues. Now chef will perform three operations, three types of operations on the stack, which he built using these two queues, right? So he built the stack using these two queues, and the following operations need to be performed. That is, if the input is 1 and the value x is given, that means he needs to add this value x to the stack, right? The second, if the 2 is given in the query, then what he need to do, he need to pop out the value from the stack, and if the 3 is given, then he need to print the top of the stack, the top element from the stack. Generally pop refers to taking out the top element from the stack. Since chef could not solve this task, can you please help him to solve this task, right? So what ultimately what we need to do, we are having two queue data structures, q1 and q2, and we need to make a stack, a fully functional stack with the help of these two queues, right? So let's see that how we can develop the intuition and just formulate the approach if we have these two queues and we need to form this stack, right? So I would recommend you to just go through this problem statement. The link to the problem is in the description. Just try to solve it on your own, develop your thinking, and if you're not able to solve this particular question, then you can watch the solution video, right? So let's start off with developing the approach. Okay guys, so now let us start with the approach of this particular problem. So here we have these two queues, right? And here we want to construct the stack data structure. Right, so some information about the queue. If you have seen that what are queues and what are stacks, if you want to know the basics, you can watch the theory portion of queues and stacks in this particular playlist. But here, just to give you a brief, what is a queue? That we enter the elements from the rear part and we pop out the elements from the front part. Entering of an element is called enqueue, and just the removal of elements is called dequeue, right? So these are some basic terminologies. In the stack, what we do is we push the element in the stack, we pop out the element in the stack, and the front element denotes the top element here, right, basically, and here is the front element is here. So these are some terminologies which will be useful in this video. So what we need to do is just form this stack from this queue. So stack is basically LIFO data structure, that is last in first out, and queue is FIFO data structure, which is first in first out. So let's say if we enter an element 5 and 5 here in the q1, and then we entered an element 4, right? So all the elements are entered through the rear side. So the first element which is popped out is 5 from here, because this is first entered, right? But from the queue, from the stack, if the same configuration was there, first 5 is entered, then 4 is entered. So the first element which should be removed from the stack is 4, because it is on the top, it is on the top. That means the first, that is the last which entered in the stack must be removed first. So this is how the basic difference of stacks and queues are there. So let's say how we can develop this. Let's say if we entered an element 5 over here, right? Now we want to enter another element, let's say 4, such that that should be popped out first if the popped operation is called. So how we can do this? We have an extra queue data structure as well. So what we do is taking the same intuition forward from that particular video in which we solved, in which we formed a queue from two stacks. What we will do, first of all, we will dequeue this number from this particular stack and enqueue it in this q2. That means this number is now entered in this q2. If both the queues were empty, then what we need to do, we need to simply enter into q1, because both of them are empty, right? If some elements are present in this q1, that what we need to do, I am telling you that, right? So just remove the element, that is dequeue the element from Q1 and enqueue it in the Q2, right? So now this element is removed from this Q1, right? So I'll just remove it. It is removed. Now we want to maintain a structure such that the last element which is entered must be removed first. So what we will do, if we want to enter 4 in this, so what we will do, all the, like this 5 element is only there, was there in this Q1. So what we have made it into the Q2. Now this Q is empty. I'll enter the element which needs to be popped out first, that is 4. This is the first element now, right? And what I will do now, I will dequeue all the elements from the Q2 and enqueue it in the Q1, right? So now if I'll enqueue 5, then it will be after 4. That means now the front is pointing to this 4. The front is pointing to this 4. Now if we call the dequeue operation must be just removing it from the queue, right? So in the pop, in the stack, if we have done pop, like right after entering 5 and 4, so the element which is removed is 4. And now if we dequeued it from the Q1, then what is the element which is removed? That is the front element only, right? Which is the element at front? That is 4, right? Earlier it was 5, because we are adding the elements in the Q1 only. Now what we have done, the number of elements that we have in Q1, we will just dequeue them and enqueue it in the Q2, and then enter the next element. While every enqueue operation will do the same process, we'll enqueue the element in the Q1 and then just dequeue it from the Q2 and enqueue it to the Q1. That means first from here to here the elements are done, and after enqueuing the element which you need to enter, then here to here, right? So this is the whole process. Let's say if we want to enqueue 3 in this, so what we will do, okay, so now what we will do, we'll just dequeue the elements from this if we want to enter an element, right? So just dequeuing the elements from here to here. So first of all dequeue 4, then 4 will be entered here, and then dequeue 5, then 5 will be entered here. This Q1 will be empty now, Q1 will be empty, and then we enter the next element, that is 3, right? After that the 3 is entered. Now we'll dequeue the elements from this Q2 and enter it into the Q1. That means first 4 will be entered and then 5 will be entered. So now the position of the elements like these, like 3, 4 and 5. If we want to pop out any element, then 3 must be removed, after that 4 and then 5, and the front is pointing to 3. That means the top here is also 3 in the stack and the queue is also 3. So this is one way of doing this. This is like making the push operation costly. We can also do the same process with making the pop operation costly, but you know the trick. If you have watched the video, the previous video, that is how to form queue with 2 stacks, then the same approach will apply by how we can do this with just making the pop operation costly, right? So we'll enqueue it in the one queue, and while popping we'll just dequeue the elements from other queue and push it into this queue, and then dequeue the and then pop out the elements, right? So this is the same flow, vice versa is the same. So this is the approach that we are taking, similar approach, a kind of similar approach that we took in the previous question as well. But yeah, this is how we make the queue with the help of 2 stacks, right? So in the push operation, what will be the time complexity? Order of n. In rest all the operations are simple operations, so the time complexity of like pop and getting the top of the stack is over 1 operations. So this is all about the approach. So now let's code this approach in C++. Okay guys, so now let us see the code of this particular problem. So here I am coding the solution in the CodeChef IDE, right? So let's see the code. So first let's look at the driver function, which is the main function. So the same process, first we are entering all the test cases, then we are making the 2 queues. Size of the input that we have given for the stack and queue is like 10 to the power 9. So we are taking long int here. So there are 2 queues here, Q1 and Q2. For each test case, we are getting a value that is A, which denotes the operation that we need to perform. If it is 1, then we need to push the element to the stack. If it is 2, then we need to pop out, and if it is 3, then we need to get the top of the element, right? So if it is 1, then we need to enter again an element which denotes the data that needs to be pushed into the stack. So what I am doing is I am making a push function, and in that I am passing the data, the Q1 and the Q2, right? Second, if the A is 2, then we need to pop out, so only I am passing Q1 here, and if it is a equals to 3, that means that we need to print the top. So I am making a top function, I am passing q1 in that, and then I'll get the output, that is the top element of the stack, right? So now let's look at the main core functions where the main logic lies, right? So this is the push operation, right? So here I am getting 3 values, and here I am taking the reference of these queues, right? Because the manipulation needs to be done in these queues, right? So while q1 is not empty, what I need to do is I need to pop out the elements, basically dequeue the elements from this queue and then enqueue it into the queue, the new queue, that is q2. So that is what I am doing. First of all, popping refers here that the element is removed from the queue. It does not give you any value, right? So first of all, we need to take the value which is on the front of the queue and store it in a variable, that is element. I am referring it with ele, and then I need to pop it out from the q1, right? So here pop operation represents the dequeue operation, and then we need to push it to the q2. Here push operations refers to the enqueue, right, in the q2. So these are the inbuilt functions in the C++, right? So we are using the inbuilt libraries here, correct? We are not just making the functions from the scratch by our own, right? So if you want to do that for practice, you can do, but here I am just using the container class of q, right? Now what is the next step? The element which we are getting as an argument, we need to push it into the q1. So that is what we are doing here, right? In the q1 we are pushing. Now the same process repeats. While the q2 is not empty, we'll just dequeue the elements from the q2 and push it into the q1. So this is how a typical push operation in the stack is formed with the help of these two queues, as we have seen in the theory. Now the next point is popping out. So it is simple, just removing the front element of the queue, that is just dequeuing the value from the q1, right? So what we will do, we'll just pop it out from the q1, correct? So here that like I am passing the q1 only, so they're taking as reference in the queue, right? The top element refers to the front element in the queue, so just a helper function which is front in the container queue will give us the value, that is the top value of the stack, right? So this is all that we need to do in this particular problem. So now let's just run this code on the sample that we have, and possibly the output would match, and then we'll submit this code on the CodeChef platform. So while this submission is happening, just a small advice to you: if you want to practice DSA problems and get a good hold on competitive, we must practice on the CodeChef platform. That is very helpful for the newcomers who are just introduced to programming. So here we are getting the output for this particular sample input of the problem. So now it's the time to just submit this code on the CodeChef platform. Okay, so let's submit the code. Language C++, and the solution is accepted. So like these type of questions will enhance your skills in the basic data structures and will give you some boost in the competitive programming as well. So if you want to learn competitive programming more, so you can go to the Unacademy platform. There you will see a section of competitive programming, and if you explore this section, there are multiple educators who are just very good in competitive programming, world finalist in the ICPC and IOI gold medalists. They'll teach you the competitive programming, and there are lots of content present over the Unacademy. So what you can do, just download the Unacademy app, or you can go through the web also and just study these concepts which are taught by such great educators. If you want, then you can take the plus subscription as well. You can use my referral code, that is Chirayu Jain, to avail a 10% discount on your course.